Okay, welcome to this question here. This is a sample mock exam from 2010. The 3D for ordinary level. The 3D graphic on the right shows a house model. Figure B3 shows the elevation and plan of the house model. Make a perspective drawing of the house given the following. The spectator point is 360 millimeters from corner A. The picture plane is touching corner A and the horizon line is 300 millimeters above the ground line. Scale is 1:4. Divide everything by 4. So 260 divided by 4 is 65. 200 divided by 4 is 50. 140 divided by 4 is 35. 40 divided by 4 is 10. 180 divided by 4 is 45. 360 divided by 4 is 90, and 260, as we said, is 65. Now, just when you look at the, when you need the plan view to do this, so you do, this perspective one, and you need an elevation or an auxiliary elevation to find this point here in plan, because there's no dimension. So I'm going to do a auxiliary elevation to solve this question. Alright, to help solve it. So we have to draw our plan view. It's 60 degrees inclination. So that line was at 60 degrees, and as we said, it's 65 millimeters is the width of the house. Okay, we have to get the middle of this line here, so we're going to have to bisect the line. Just need the visualizer there, give it a bit better lighting. So swing an arc here, swing an arc there, then on to the end of the line, swing the arc, swing the arc, and that's the middle there, and going to be the middle of the house. Okay. Right, now, so it's the house is 90 long. So I can mark this in here. This in. Okay, now what was I going to do there? I'm going to focus now doing the little dormer of it here. Alright, the little extension at the front. This little extension here at the front. Now, if I look at this here, so this is 360 minus 180 equals 180. So there's 445 segments there. There's 4 22.5 millimeters there. 22.5, because 45 divided by 2 is 22.5. 22.5, 22.5. So how am I going to get that here? Well, what I'm going to do is draw a line at any acute angle. I'm going to make it a number easily divided by 4. So I'm going to just draw this line here, and I'm going to make it 8 long. I'm going to step 2, 4, 6, 8, and then I'm going to join this point here to the corner there, and all subsequent lines are parallel then. So there they are, and the dormer window is going to be along there, and it shoots out by 10.
How would I get my book?
So there's the points there. Now the dormer extends out 10 mils, so light lines out here. Okay, and we can measure our 10 mil and heavy in here. The issue we have is we don't know how far the center line is going to go back into the house. Okay, so that's just light there. Now I get the lights up and running there, so you can see better. So the lights will be coming on in a short bit. So the problem is we don't know where that point is. So what we're going to do is we're going to take an end elevation, or sorry, not an end elevation, no, auxiliary elevation, because what you want to do is see the roof here as an edge, as a single line, and that when you see it as a single line, you'll be able to work out where they meet. Okay, so in order to get a surface to appear as an edge, you have to look along the true length of a line on that surface. So I'm going to look along these two lines, because this line is the true length in plan, because it's parallel to the XY line elevation. I'm going to draw in my X1, Y1 line. That can be at any distance out you want, so that's the X1, Y1 line there. I'm going to continue this here. Now the height of the center of the roof is 65 from the horizontal plane. So 65 here, and then it's going up 35 for the start of the dormer, so 35 there, and then the next one then is going up 50. So we're going up 50 here. We can join these together. This is an edge view of the roof. Okay. At this point here, and then this, the roof then is going out. It's going out there. Here we have it here. So just 1 second there. So once we have that now, once we have that, we can take this point back to here, on this one back to there, and that gets the point where your roof stops, and then we're ready to nail into the perspective question. Okay, the perspective section. And now it says the spectator is 360 mil from corner A, and it's when you look at this diagram, it's saying S is just straight down. So we can draw a line straight down and measure down 90. Okay, so there's the spectator. I know you can't see that, so I'll move the visualizer closer. So here's the spectator. You must join the spectator to the two outermost points. Okay, and now to get the picture plane, you got to bisect this angle. I don't know where there's my compass. So you got to bisect that angle. Okay. Just tiny bit off there with my bisector, so I just change it. Now the picture plane is perpendicular to the bisector and it's passing through corner A. Now your horizon line is always parallel to your picture plane. So there has got to be something. I think I'm cut or something. My page is getting awful dirty. but however we'll just tear on with the video. Now I'm just going to move this visualizer there for a moment. So one sec here, so you can just get a better view of what's going on in the question. So there, we've fixed that visualizer. Now, so as I was saying, the picture plane is always parallel to the horizon line and ground line. So I'm going to draw these in, and I'm going to mark in my horizon line, and it says the horizon line is 300 mil above the ground line in real life. So 300 divided by 4 is 75. So I'm going to measure down 75, and there's going to be my ground line, and I'm going to mark in my ground line here. Now what I need next is my vanishing points. Okay, so to do that you need to establish one set of parallel lines, so like 1, 2, 3, 4, they're going that way. The other set of parallel lines are going this way. So your vanishing points are found by going parallel to each respective set. So from S there, we're going to draw a line at 60 degrees and 30 degrees. And where it hits the picture plane, you're going to go perpendicular to it. So here's the vanishing point on the horizon line, and here's another vanishing point on the horizon line. So I'll call that VP1, VP2. Now, your best thing to do here is join all the points in plan. I just need to move the visualizer. All the points in plan to the spectator. Okay, so I'm joining all the points in plan to the spectator. Okay, so I have that done. The first thing I'm going to do is bring down a point that's on the picture plane. Right, so I'm bringing that down perpendicular to the picture plane, which is this one here. And from a point on the picture plane, you can put in true heights. So the height of the front edge of the house is an altitude of 35. So I can measure now 35 here. I'm going to join that in. Now, a baseline is going to join to here and here, and we're going to measure off to draw off rather to VP2 and the horizon line. Now, just bearing in mind my light lines are a little bit darker on the video to make it easier to see. There should be this one here, which is not easy to see, at least for me on the screen, is the sort of weight a light line should be. Okay, now the house ends here, which is this point in plan. So if you join this point to the spectator, where it pierces the picture plane, we go down perpendicular to that. So that's going to be the end of the house. And then the same the other side. Look, join this point to the spectator, and where it pierces the picture plane, down perpendicular to it. And this is the end of the house. Right, now the trick is now how to get this point here on the roof. Now only true heights can be applied from a line on the picture plane. So if I join this point here to the spectator and down perpendicular to it, the apex of this roof is going to be on that line. But I can't measure the height here because it's not on the picture plane. What I have to do is extend it out till it hits the picture plane, go down perpendicular to it, to the picture plane, and I'm going to measure the height of that. So the total height of the roof is 65, so I'm going to measure 65. Now this line will be going towards VP2, so I'm going to join it to VP2, and then where it pierces this one, this is the point on the house. So I can join this one, and now we're beginning to suck diesel. Okay, now I want to get that point next. So this point here is this one in plan. I join to the spectator where it pierces the picture plane. I go down perpendicular to the picture plane. And now see where it hits this line going from the apex of the roof to VP2. That's your answer now as to where it is. Okay, next part of the question now is we'll do the dormer. Okay, so what I mean by the dormer is the little extension here, the little porch. Okay, so I want to get this inside line here first, then I'll focus on getting that one and the heights. So this point here where it hits the picture plane, down perpendicular, so I think I can zoom up here to make it just a bit easier to see. I'll just adjust the zoom there to aid understanding. I'll put auto focus lock on. Hopefully that's good. Now, so we're going to bring this inside one in. So it's the inside edge. Now, if I want to get this line, what I do know is this line here and this one, okay, they go to VP1. So if I work backwards now, and I go from VP1 out through the bottom of this, if I want to get the front of the house, so that one there, I find that point that I'm thinking about in plan. So this one here, join to the spectator and down perpendicular to the picture plane. What you got to be good at is locating points in different views, visualizing where they are. Okay, now same idea again with the roof. Perspective is pure logic. Like once you get the logic behind it, you're sucking diesel. Now, this point that I'm going to show you now in one moment is down here at VP2. So we're going to join this to VP2. Okay, we want to get where it stops. Okay, so this is where it stops in plan view. So join that to the spectator, down perpendicular. Okay, and we're looking for this edge here. Okay, so this one here. So it's along this level. Okay, or sorry, this one is what we're looking for. So if I join VP2 through to this one, where it intersects gives me the height. And I can now join there and here. Now all I really need now is to do the little roof section. Okay, so I want to get this point here. Now, as I was saying, only true heights can be applied from a point on the picture plane. So if I extend this line here and where it hits the picture plane, down perpendicular to it, and now I can measure from the ground line. So the height is 50, so I'm going to measure up 50 from the ground line. I'm going to join it to VP2. It's got to go to VP2. Don't make the mistake of bringing it to VP1, because that'll mean it'll be wrong then. Right, so I go perpendicular to the picture plane, right, and it's from, look, join this point to the spectator, and where it pierces it here, down perpendicular. So here's the apex of the roof. Okay, now I want to get where they meet at the back. So this line goes to VP1 in real life. So I can join this to VP1. Have a think now how you'll get that point in plan. If you can do this without the video, go on ahead. Feel free. Just use the video at the end to check that you're right. Okay, so this is the point we want to bring down. Slide this down here. That's where it stops. Okay, and now you can join this together. This one to here. Here we go. And now. And there's the question complete. Alright, so no better subject than the drawn. Right, cheers, thank you, bye bye.